So, hi. My name is Yuriy Tymchuk. I am finishing my Ph.D. finally in the software composition group in the University of Bern. And today I will talk about the last features that we added to the Pharo quality engine. Well, essentially, probably you saw me last year's, and I was talking about these amazing, cool new features. And this time it will be more like the things that were missing all the time. So as Apple does High Sierra, this will be like high quality engine. Anyway, you probably saw Quality Assistant if you work in Pharo or if you were there for last ESAs. And essentially this is this small plugin at the bottom that spits out the warnings about your code quality as you program. But Pharo code quality is not only about the Quality Assistant. Because Quality Assistant is just in coding browser. You also have quality feedback in message browser, in critique browser, which is a dedicated tool, and also in the debugger, because a lot of people program in the debugger, so you also want the feedback there. And all these things are powered by Renraku, which is the model of quality behind all this stuff. And lately we integrated the Renraku 1.0 into Pharo 7 development version. And it has some nice features which I want to talk about. But to give you some perspective, Renraku is something that I have developed for 3.5 years or a bit more. And that was a lot of work. And the point is that, well, my PhD contract ends, and after that I cannot promise that I will maintain that. Thus the final strokes. But there is any hope. So this summer Pharo got Google Summer of Code slots, and Miroslava was working on the support for quality rules. She's right there. Can you stand up? Okay, so she's still a student, so maybe you can make her to fix the bugs that I left. Yeah, let's go into the actual features that we have. There are quite a few. First of all, we improved the code coverage by tests. It went up by 20% to the whooping something 46% or something like that. And that's actually great because there are a lot of stuff that are hard to test, but all the new features are tested. So I made a rule. If we integrate the pull request into Renraku, you're not allowed to decrease the number of coverage. And it's really hard to keep it the same, so you slowly increase that. Now for real features, we have an advanced banning for rules. Now, from time to time, when you see some warning, you do not agree with that. It may be a false positive or just not the way you think that things should work. And you have this nice little red cross there, and if you click on it, it asks you where do you want to ban this rule. You can ban it on the exact method that had the violation, so the exact method will not be reported again. You can ban it for all the methods of a class where this method is, or for a complete package. But we have a lot of quality rules in Pharo, and it's normal that not everyone agrees with them. So if you don't agree with some rule, the only option that you had was just to ban it for your packages all the time. Now, you have more options. You can ban a rule for a whole image, or you can also ban it for the future images. And this is implemented on top of settings. So essentially, each rule has a setting associated with it. And when you ban it for the whole image, it turns off the setting. If you ban it for future images, it uses the settings persistence API to save the setting. And then in the future images, it will be also banned. And this is really great because someone may ship a rule which is disabled by default because maybe it takes a lot of time to compute or it's some really special rule. And then you can enable it in the settings and persist it and so on. But there is another question, like, okay, everyone has his own ideas about which rules should be followed. But imagine the Pharo system itself. We have this nice idea that all the classes should be commented. And you shouldn't have a reference to an undeclared variable in your code. I think these rules make sense. And it's okay if someone thinks that they don't make sense and bans them for the complete image. But they are still valid for Pharo packages. So now you can specify that some rules should be always validated for certain packages. And for example, here in the Pharo kernel package, you specify that some rules like uncommented classes, unclassified methods, unreferenced variables, they should be also always validated. So someone can disable it for all the image, but if you are changing Pharo code, we will tell you that you have to follow certain rules because we impose that. One thing which is on the way to arrive is an option to quickly validate it on the CI server. So again, when you run your tests on Travis, you can also run this enforced rules because they are enforced, so they should be followed. And then this is the way things are checked. So when a rule tries to validate a method, it first checks if the rule is banned for that method, or for that class, or for the package, or for the image, and so on. And this is important because now for packages, you can either ban rules or enforce rules. So everything which goes before package is more important. If you ban the rule for one class in the whole package, it's okay. I mean, you have a unique class. But if you ban the rule for the whole image, but it's enforced in the package, it will still work in the package. And at the moment, you can ban the rules on the level of methods and classes, and you can ban or enforce them on the level of packages, or the whole image, or the whole image and the future images. And that's the first major feature. Second feature is, of course, about error handling. We are not responsible for the rules that people write, because you can take some rule from some other package, and then it will validate your code. And this is great, because you're not constrained by a single set of rules. But the problem is, what happens when there is a bug in someone's rule that you are using? Something like this. Okay, each time when you select something in your browser, it runs the validation and it breaks. And this is really frustrating. Okay. So, I mean, it's good to know when something goes wrong, but it's really annoying when someone is always yelling like there is a problem. Okay, I know. So, the obvious solution that we actually had for some time is just to mute that. This works. I mean, if someone codes, it doesn't bother him just because some rule that he is not responsible for breaks. But it looks like everything is awesome, but then we have no clue what is happening. As a user, you're working and something breaks, and it would be nice if you knew that it broke actually, because then you can ask the rule maintainer, can you fix it because I like this rule and it actually broke. As a developer, well, you want to know that your things are breaking, and by default we had a setting where you could say, okay, actually show me all the problems, and then you got this flood of things flying at you. But now, there is a really nice solution. So you have your critiques, but also with the critiques, you have another thing which says, you know, there was an exception, and in this case, this is a method not understand exception, and as you can see, there is a green bug icon. You can click it, and you can debug the thing that happened before. Of course in post-mortem, but still we keep the stack, so you can debug it. And it's nice because users know that something happened, but they are not taken from their workflow, just a new thing appears in the list. And developers can actually see that there is a problem, and they can debug the problem. And when you think about this, It may be a bit complicated solution, because you know when exception happens, you have to store somewhere the information, and then you have to append list with another items, with the special things. But this is not the case in Pharo, because this Renraku framework, it actually works on properties and not on critiques. Critiques are things that people see most of the time, but they are just one of the subclasses. And then a critique knows the rule that created it. It can use the rule name for the title, and it can ban the rule if someone wants it, and it can apply autofix based on the algorithm in the rule. But on the other hand, if you have exception property, it stores the exception message and the context. And then it can use exception message to display the thing, the message of the exception in the title of the critique. And it can use context for debugging. And that's really nice. So implementing this special behavior, it fits on the postcard. A slightly bigger postcard, but still on the postcard. And I cannot go now into much more details, but tomorrow I will give a really technical talk on IWST about how Renraku is modeled and how you can do things with it with demos. So if you are interested, please visit that talk. To sum up, you at the moment have three options still in the image. First, let everything pass, so it will scream at you. Ignore everything, so you will not know anything, but by default it logs the things, it packages them nicely and shows you together with other information. And the last major thing that we did, we actually revamped all the quality rules. And for me, the idea was that by doing that, Nierstrasz will learn something about the rules and then abandon that. But we actually went through all the rules. It was a really tedious job, but we got some nice results. To give you some overview about how rules work, this is kind of the hierarchy which is there. So you have a rule, and then you have rules that take classes and check them, and then you have rules that take methods and check them, and then there are some special rules which use parse trees and which are transformation rules. Transformation rules are really nice. This is an example of how you define a transformation rule. Essentially you say, okay, I want to replace this code with that code. And then you see that there are some variables with backtick at sign, which means that they will match anything which is there, and they will keep it during the replacement. So this is nice because you can read it as an actual code, and then you do not have to implement some special rewrites. It will rewrite it for you, and it uses the refactoring browser engine for that. Now, how this actually works? What you do is you parse source of a method that you are checking into an AST. Then you traverse that AST. And then for each node, you check if it matches the rule. Because actually in rule you do not specify the whole method, you just specify some snippet which is a source code node. And then if it matches, it rewrites node on the go. So it goes through the whole AST and it creates a new one. And then you can use it to replace your existing code. And then, if you are checking a single method with like 50 rules like this, it will do that for every rule. If you don't see a problem, it will parse the thing 50 times. This is slow. It will also traverse the thing 50 times, which is also a bit slow. And all this stuff is done by every rule. Now, if you look at this, the actual thing, which is rule specific, is down there at the bottom. Whether the node matches something defined in the rule. So what I did, I thought, how about we switch things around? So you parse the thing only once. You go over the AST only once. Then you check, actually, if each rule matches a node that you are at, and if it matches, you do not rewrite it in place, you do not break the AST. You actually save it, so if in the future someone wants to rewrite it, it will be rewritten. And then you see, this is the only thing that the rule has to do. It has to check nodes, not do the alt traversal and things like that. On the other hand, there is another evidence that we need rule that check nodes specifically. Look at this example. This is a real code taken from Pharo image. I have formatted it a bit so you can actually read that. But the main idea is that if you see there is backtick and curly brackets. And this means that it will match any node and then it will run the code inside, which is in a string right now, so it's really not easy to debug, let's say it like that. And then it checks whether the node matches what you have in the block. And you have a lot of rules like that. So it's like screaming, we need rules that check single nodes. So that's what we did. Instead of this, we created something like this. You have rules that check methods, but you have also rules that check single nodes. And then the matching rules and the rewriting rules, they are just a subtype of that. Let's get back to the previous example. What this rule does is it checks whether you use collect, detect, or select, and if you do not use the result of that, because this is strange. Instead of this, now you can implement it like that, which is almost the same, just in real code without strings. And the implementation is simple. You check whether it is a message. If it's not, you go out. Whether it sends the thing that you're interested in. If it's not, you go out. Whether it's used, if it's used, you go out. If not, you create a critique. Now another example. So here, it matches a literal, but then again, it goes into all this thing and it checks if the literal is actually what you need. Again, this can be solved with a node rule. You just say, okay, is node the literal array? If not, you go out. And then you check the other things, and if they work, you create a critique. As simple as that. There is another fun example, because this is not a pattern matching rule. This is just a method checking rule that checks if you send some strange messages. So they have this bad selectors, which are like halt, perform, other things, just to warn you, like, you know, normal users shouldn't do that. And what they do, they use sends any selector off, and sends any selector off is shown here, and then you can dig deeper and it actually checks the bytecode if the bytecode has this message sends. And if you want to debug this, this is a pain. But if you think on the other hand, what you're looking for, you're just looking for message nodes with certain selectors. That's it. Okay? And then, you know, because Miroslava did this as her first transformation, as a creation of node-based rule, and then I asked her, well, can you check if it works well, if it detects the same stuff as the previous rule was detecting? And then she said, like, oh no, something is bad, it detects more. This wasn't bad, you know? It detected case of otherwise, which is compiled into jumps in the bytecode. So you cannot detect it in the bytecode, but you still want to warn a person, like, you shouldn't do that. Also, surprisingly, it turned out to be 7 times faster. Don't quote me exactly on 7, okay? Maybe it's 6, maybe it's even 5. It's much faster. Because it turns out that going into bytecode and checking if there is this selector actually takes some time. And then all you do here is like, oh, are you a message node? Are you this selector? And in the end, you have the actual interval of the source code. Because even if you know that the bytecode has this selector, you cannot highlight the place in the source code where the problem is. But with AST nodes, you have this information. Okay, let's get to the fun part. So, you know, I want to make you feel the pain that we felt when we converted the rules. This thing checks whether you get some collection from somewhere and then you modify it by adding elements to it or removing elements to it. This is a bad practice. And then you do not need to understand all of that. Just look at two places. First of all, it assembles the matching strings on the go, which is hard to understand. Secondly, if you look in here, when it actually matches the node and it needs to do additional analysis, it does like, oh, you know, receiver is node, receiver, receiver. Because you match the complete thing here, but then you need just an object, and then you know you go to the receiver, receiver, and sometimes it's arguments first, receiver, receiver, and other stuff. So what we did, well, first we wrote this in the plain text. There is a lot of duplication, but you can look at it and you can understand what it does. And this is the whole method, so it's just 6 lines of code instead of 3. Secondly, this is the after checking algorithm, and what you can see here, we have a mapping dict. So instead of going, oh, tell me your receiver, receiver, we say, what is your mapping at the collection owner? Because this dictionary is available when you do the matching. Like when you do the matching, you cannot do it without this dictionary. So you already have it, but you never had an access to it. Now you can do that. And it's actually nice because now you don't have to say like, yeah, you know, we go to receiver, which is a receiver, receiver. No, you say, okay, this is a collection owner. You work with a collection owner. This is another nice example. So, as you can see here, we have this weird construct, which essentially check a node, whether a node is a literal node, and whether it is actually a float. Okay? And you do this 4 times. Like in every line, you do the same stuff. As you can imagine, when you open this thing and you look at that, you think like, whoa, this is really complicated. Well, in the new version, it's like that. You say, okay, float literal is equal to expression, or equal with another thing, or so on. But you also need to define what is a float literal, so you have another method, which is again one-liner, just checking if it's actually a float, if the matched literal is a float. And I don't know if you noticed it here, but the final example is really fun. This is a rule that checks whether you do like, you have a variable and you check if it's equal to this literal, or it's equal to that literal, or it's equal to this literal. Instead of this, you can just have an array of literals and ask whether it includes the variable. So, you see, first of all, you have a big things that are matched, and then you do, when you match one of these nodes, you do is searching literal expression. Now, what this does is really fun. So you say, we need an equal node. What is an equal node? Now, we got a node. Is the selector a pipe? If it is a pipe, then we take a first argument. So if it is a pipe, it matched one of this. So it selects this half. If it's not a pipe, it's one of this. So we are actually going to this part. Okay? Now we have equal node. Good. Now we need an expression node. What is an expression node? Well, is equal node receiver a literal? So we check, like, if you have these 4 things, are these 2 things, or is it about these 2 things? And if it is a literal, it assigns the other part. If it's not a literal, it assigns this part. Who understands how it works? Exactly. You know? I opened this and I was like, arguments first or a receiver. So my point is, I kept the same stuff in the new code. I mean, it's okay. But then what we do, we just say, mapping dict add object. That's it. And it was always there. And this is all the code that you need. You know, because then, yeah, we reuse this stuff from the old rule. But instead of actually jungling things around, we say, okay, please find this stuff and find the object. And it found the object. So now do it. I hope that I convinced you that this is actually then this is actually more readable, let's say. But now the question that I always get, are these speed improvements really worth it? I mean, yeah, we do this in a loop, we parse the thing. Is it really worth it? So what we did, we actually took all the methods from the Pharo image, ran all the rules from the Pharo image, from Pharo 5, Pharo 6, and the alpha version of Pharo 7 that has our changes. And we tried to calculate the average speed, how much time it takes to check one method by one rule. And these are the results. Over 2 years, we got a speed up which doubled. So essentially, when you needed 10 minutes to run all of the rules in the past, you can do it in 5 minutes now. And this is just because we changed how the data structures are organized and how we do things. Yeah, so that's it. As I showed you, we have advanced banning that allows you either to enforce things or to ban them, or to enforce and ban them, or to ban and enforce them. You can have a really nice error handling that involves special properties that have exceptions in them and so on. And we changed a lot of the rules. So now they can give you intervals, they are fast, they are more understandable for the people who will come and who will read the code. As I mentioned, there will be a technical talk about how this model works. So please come tomorrow to the beta room, which is not this room, the other room, at 3 p.m. or maybe a bit earlier or later, around 10 minutes, I guess. And that's it. That's Renraku. Thank you. Yes, please. Questions?
I really like your approach to go through the Parse tree, and but this popped a question into my head, and that is, so you showed I can annotate a rule that it is not run in a method and not run in a package or not on a class. Can you also think about saying, oh, I want this rule only not to be mentioned for this particular piece in the code, or the other parts of the same method shall be checked? So going with the application or with the rule not to apply a rule even into a method in a more detailed thing, as you did for the rule itself.
Let's say I thought about this, of course. And there is another problem which I am thinking about. The node rules, they are not the same as class rules or method rules or so on. Because actually node rules are run when you check a method. They are just run in a specific way. They can be run to check a specific node, like if in an inspector you open a certain node and you check it, you can do that. But node rules are different. So that's the question. Like when you check a class, it doesn't run checks on all the methods. But if you check a method, it runs the check on all the nodes. So whether we should make them more uniform or not, I have no answer for this at the moment. And then, is it possible to ban them on a certain piece of code? Of course it is possible. I mean, I can implement that. The question is whether it will be really used. Because how many methods do you really have that, like, you want to have a report about a single method in one place but not in the other place? Maybe there are these use cases, so I want to hear about them, but mostly the development is really like requirement driven. So there was no like global banning and enforcing, but then people really said like, I want to ignore this completely, and then we want to be able to enforce things for Pharo kernel or whatever. And that's why I did that. And if there are use cases, then it will be interesting to experiment with that. But at the moment, I just don't see that I cannot imagine that it will be useful.
you show in the diagram new here rules. Do we really need distinction between match rule and rewrite rule? Imagine that I have some deep hierarchy of match rule which not defining rewrite approach, and then I create new which reuse superclass behavior, but here I know how to rewrite it.
Yeah, I think that this is a good question. One thing, like the reason why, partial reason why the things are the way they are, is because I was migrating from small int, and I tried to keep things similar to it so I can gradually migrate it without breaking stuff. The difference between, so essentially there is one common ancestor of match rules and rewrite rules that have a common functionality. I don't remember what is the difference. I think that the main difference is that match rule has just the array of matches, and rewrite rule has a dictionary of matches and rewrites. Or maybe it has associations or something like that. And then during traversal you detect the match, and then you also, if you detect, you create different critiques. We can look at the code. For some reason I wanted to unify it, I didn't do that. But maybe it's doable. Any other questions? There is a question.
There is one question, yeah.
After I will interfere.
So I find it very interesting what you're doing, and I will give you an application case where you didn't find one for the answer of Mr. Heek. So I think if you really use the quality check, then you will have rules in the company like only fully checked code has to be published. And then you start with the problem, okay, if I ban some rules because they give false positives, I have only two choices. The one choice is to leave the rule in and publish with warnings or whatever, or to rule it out totally. So I think an approach that gives you more abilities will be interesting for a really better way to check quality. That would be my opinion.
Yeah, I would like to hear use cases. Like if you will encounter a use case, please send me an email, and then we can try to find a solution for that. It's just that if I will try to imagine problems and create solutions for them, you cannot guarantee that anything good will come. Yes, it could solve the problem, but it's a big discussion about banning and not banning and false positives. Because also, I mean, if you think about the rules, there are some rules that are really useful from my point of view, like undeclared variable. You remove the variable and you forgot to remove the method that uses it. So it's really important rule. But there are some rules that just hint you like, are you sure? Maybe you made some refactoring and you didn't look at here. So, and then if they are not fixed, it's not that bad. So then I think that there should be a small set of really enforced rules saying things should be like that. And if you ban some in a small locality, then it should be also present in the commit. So either in the commit you see that there is no violation, or you see that there is a ban and other people during the review approve that, okay, this is the correct ban.
We'll talk in the break.
Of course.
Thanks, Yuriy.
Thank you.
That's cool.